हरिः कर्ता।
So this intuitive plots for you course consists of 5 subparts. Out of that, the first part is basic plots. So in basic plots, we will be drawing and looking into plot, scatter, bar, stem, step, and fill between and stack. These are different types of plot methods from Matplotlibs that we are going to do. So this is the first part of intuitive plots for you course. So we will begin. Okay, we'll begin with plot, a plot x comma y. So before that, let me set up my Jupyter notebook dashboard. Go to the hands on and click on open PowerShell. Type Jupyter notebook and execute it. And let me take out this, and here is our Jupyter notebook, and here I'm gonna open new intuitive path. So new IPython kernel. So the name would be, I'll be giving so plot types anyway. So these are basic plots, just plots. And so let's begin with the basic plots. So out of the basic plots, we'll begin with plot. Plot x comma y is our first one. So let me execute and get back to the slide. So what's plot x comma y? So using this plot x comma y, we can draw some of the fundamental graphs such as sinusoidal waves, or even you can draw the line graph as such. If you take a line graph, so what is a line graph or a sinusoidal wave? So what actually happens, what they represent, why do we require a graph? So a line graph displays a sequence of data points as markers. So the points are ordered typically by their x-axis value. So these points are joined with the straight line segments. A line graph is used to visualize a trend in data over intervals of time. That's what the line graph. And similarly, we can look for the sinusoidal wave. So because that's what we are gonna draw here. So what is a sinusoidal graph, sinusoidal plot? And how does it helpful? So this is widely used, so you can see that this is how it looks. And for what we use it, so the term sinusoid is based on the sine function y is equals to sine of x or cos of x. So graphs that have a form which is similar to the sine graph are referred to as a sinusoidal graphs. So here the periodic nature of the sine graph is what makes that shape. So it repeats every 2 pi and has a smooth curves. So how do we plot a sinusoidal graph? Using Matplotlib. So that we are gonna see. So but why do we require a sinusoidal wave? Why are we looking into it? Because lot of wave motions were represented. Example, electromagnetic radiation or radio waves are a lot of waves which are there motion is fundamentally represented using sinusoidal wave. If you take electric current, that's AC, alternating current. The alternating current is also represented with the AC, so with the sinusoidal wave. So sinusoidal wave is very important. So that's why we are beginning with this, because see, most of the data scientists might be watching this. So for them, so the mathematics is soul of their job. So now I just want to apply the mathematics to the business using Matplotlib. Let's do that. Let's do one example first. So let me take, as usual, we have to import matplotlib dot pyplot. And how do I want to import as PLT? Execute it. Yes, it's been imported. At the same time, I also require an arrays. So for arrays, I'm gonna take import numpy as np, and here is that. So our PLT and NP, so both has been imported successfully. So NumPy and matplotlib.pyplot both has been imported successfully with the aliases NP and PLT respectively. So now let's make, so PLT dot style, I'm gonna use use method, and my argument would be underscore mpl gallery. So that's what, and done. So now I need to make up a data. So let's make up a data. Let's make up a data, and let me take the x array. So x array will, I'll use np dot linspace, and so from 0 to 10, and I want to make it as into 100 fractions, 100 fractions. And then similarly I require a y. So y is equals to, this time I'm going to take an equation. Obviously it's a sinusoidal equation, so I need to make a similar kind of equation. So 4 plus 2 times np dot sine of, it's sine of 2 times x. So what we'll do, let me execute and let me print x, and this is what we got, and let me print y, and these are the values we got. Okay, so hence we have our x array and y array. So both the arrays we have, so that we can plot them on x-axis and y-axis respectively. So now let's plot it. So data is ready. Now it's time to plot. Let's plot. So to plot it, so what I'm gonna do, so as usual I'll take two objects, one is fig and the other one is ax. So fig is equals to ax, and plt dot subplots. So by the time you should have known, and you should have made out that I'm using object oriented code style. It's called explicit code style. So I'll go with the subplots and then execute, and here is that. So this is a subplot, we got it. So now what I'm gonna do is, inside that I'm gonna create a plot by adding these x comma y values to my plot. So xd plot, and x, the data to be plotted on x I'll take as x array, and the data to be plotted on y I will take as y array that I have defined on top. And then line width, not line space, line width is equals to 2.5, and execute. Okay, and here is your graph, here is your sinusoidal wave. So now what I'm gonna do is, I will change the limits of x and y axis so that we can have a comprehensive graph. So ax dot, let me use set, and inside that let me set the x limit 0 comma 8 and x ticks, that's np dot a range, that's 1 comma 8. So this is done. This is one tuple from set of x limit, this is x limit from 0 to 8, that's done. The next ticks is 1 to 8. Okay, these two are done. Then similarly I have to give one more argument, so two arguments as given. Now I have to give y limit. So y limit, I'm gonna give one more tuple, that's 0 to 8. Now I have to give the y ticks. Y ticks is 1 comma 8, and that's it. Limits has been added, and here is that a brilliant plot. So this is 1 to 8, in between you got it, and here it's 1 to 8, and so it's looking fantastic. We got the exact let me add this. Yeah, that's it. After attaching the plt.show, if you remove this, so why we using the show, see, this is what you get. You get the complete information, like what all were saved at which location. So axis x tick at this memory location and y tick at this memory location, and all this information is not required. Just to remove all those information, just you say plt dot show and execute, and here your image will be ready. Fantastic. And you see that the sinusoidal wave, and this is what we call it as a plot.